As Tania said, I'm going to talk you about tracking tangled evolution to assess systematics of the Triatoma phyllosoma species group. My presentation is based in these two papers, so I suggest you to check them for further information. Well, the Triatoma phyllosoma species groups includes 17 species of kissing bugs, most of them implicated in the transmission of Chagas disease in the Americas. Because the medical relevance, there are a large amount of data about them. However, the validity of some species of the group was uncertain because both critic species and hybrid occurrence. Resolving the evolutionary history of the Triatoma phyllosoma species group has proven challenging. For example, mitochondrial and nuclear gene trees show considerable topological incongruence. Incongruence between species tree and gene trees is an intriguing pattern. Here we can see the red gene tree and the green gene tree show us very different clustering of our taxa. Let's go and assume that the red gene tree came from mitochondrial data and the green gene tree came from nuclear data. This is because independent losses tell us different histories. Incongruence of gene trees came from different processes. For instance, incomplete lineage sorting. Here, the gray gene tree show us the species tree, the real phylogeny, but we can see the gene tree too is different some of this species tree. And this is because their and their taxa share an ancestral polymorphism. As a consequence, we retrieve some incongruence between these two trees. Another process that causes gene tree incongruence is introgression. I believe that some of us grow up believing that introgression is not possible between real species or consolidated species, but it is actually some common process. Even for us, I bring you one very known example that is for human and Neanderthals hybridized in the past, and as a consequence, we as humans have some introgressed haplotypes in our genes, but we are actually humans. So introgression is a part of nature. I invite you to take in mind that these two processes can be retrieve the same pattern, gene tree incongruence. So an important question is how can we difference when we are talking about incomplete lineage sorting or introgression. An important difference is introgression is a process that is actually happening in geographic space. As we can see in this diagram of the left, hybrids are spread on the hybrid zone. What happens with hybrid in the future? Well, we can retrieve several possible outcomes. That depends on every case, but it's a process that we cannot deny. So our main aim is to infer a robust phylogenetic hypothesis for the Triatoma phyllosoma species group by first excluding samples with sign of introgression and then modeling incomplete lineage sorting. We describe an approach to disentangle the reticulate evolution of the Triatoma phyllosoma species group. This approach consists in these steps for detecting signals of hybridization and introgression. The approach integrates information for biogeography, reproductive ecology, and gene trees to derive a robust phylogenetic hypothesis. The diagrams illustrate the case of two species, A and B. Hybridization becomes more likely when species distributions overlaps and species are interfered. Under this biogeographic ecological context, introgression is a protective cause of mitonuclear gene tree incongruence. The right-hand panel, gene trees, suggests that individual A2 clustered with species B, yet it belongs to species A. Excluding individual A2 from the phylogenetic hypothesis dataset reconcilies gene trees and species trees, despite gene flow between A and B species. So, considering our first step about biogeography and cross-fertility, I retrieve potential for hybridization among members of the Triatoma phyllosoma species group. It is some group of hypotheses if couple of species is a hypothesis of hybridization. In this diagram, circles represent the approximate center of the distribution of each species in Mexico, while edges connecting circles represent the degree of spatial overlap. We can see that some lines are wider than others, and this is because wider lines represent a big degree of spatial overlap. Red couple of species represent interfertile species, and black couples intersterile species. In this step, we are acknowledged that there are several cases where hybridization cannot be denied. for our second step is incongruences between gene trees. On orange and green, we can see that just two samples show gene incongruence. In this case, Tratoma picturata and Tratoma huehuetenangensis. Tratoma huehuetenangensis was actually known that very close to Tratoma dimidiata. Now we're gonna retrieve these two hypotheses about the phylogeny of the Tratoma phyllosoma species group using Bayesian multispecies coalescence analysis. In the first case, I used the complete data set. And in the second case, I used the data set without putative interword samples. This is picturata and Tratoma huehuetenangensis. The first case also only considers incomplete lineage sorting of the processes involving in this phylogeny. And the second phylogeny considers, or the second hypothesis, considered incomplete lineage sorting and hybridization as processes occurring in the history of Tratoma phyllosoma species group. We can say that only two samples can cause a large amount of difference. In the first difference, we can see the topology in orange. Let's check Tratoma picturata. In the first case, Tratoma picturata clusters with Tratoma pallidipenis, Tratoma masolse, Tratoma masotti, Tratoma phyllosoma. And well, we can use this like a polytomy, but Tratoma picturata is not clustering with Tratoma recurva and Tratoma longipenis. The second case, Tratoma picturata cluster with Tratoma recurva and Tratoma longipenis. And this hypothesis is actually better resolved than the first one. Another difference is about a branch length. I think we might take some attention about it because we are talking about one single sample. And well, sometime in the past, I don't know what right now, but most of our studies were based on one single sample, and our hypotheses were based on one single sample. So these samples cause a lot of difference about branch length. And in the first case, Tratoma dimidiata, Tratoma huehuetenangensis are, we can see that are a short branch. And in the second case, Tratoma dimidiata, Tratoma huehuetenangensis, the branch length is longer. If we translate this to time, we may have some differences. Considering the performance of our hypothesis, information about previous data, we prefer the second one hypothesis. And we use this hypothesis to implement and as well implement the cohesion species concept for validating the species status of this species. I think our stories illustrate how explicitly integrating biogeographic and interspecies cross-fertility information can enhance phylogenetic inferences when introgression produces incongruent gene trees topology. Thank you so much, but I'm expecting some questions from you.